Hello students, now in revision lecture of unit 3 we are taking our second sum, second method also in t-test. Our question is of March 2019, question 4b of 7 marks. To check proportion of nicotine is same in tobacco, two samples are drawn as follows. Sample 1 is given by 24, 27 till 25, and sample 2 is given by 27, 30, 28, 31, 32 and 36. Question is asking that can we say that there is no significant difference between two sample mean from this data? Okay, we have to check significant difference between two sample means, so we have to apply t-test for this. See, it is quite lengthy and tedious method to solve this example. Now we are solving this one. First of all, our null hypothesis H0. We can write there is no significant difference between two sample means. Or we can also write H0 proportion of nicotine is same in both the samples of tobacco. Or in short, we can write x1 bar equals to x2 bar means sample means of two samples are equal. Okay, we have to write only one out of these three null hypotheses, and this is very comfortable for us. X1 bar is equals to x2 bar. Okay, now we are preparing our table for calculation. So concentrate here. First write down x1. Say x1 is equals to sample 1, 24, 27, 26, 21, 25 dash. Total is 123. From this data, first we are finding x bar. X bar is equals to sigma x1 upon n1. 123 divided by total 5 observations. We get 24.6. Okay. See, our x bar is in point 24.6. So we have to use shortcut method for standard deviation. So here we are assuming a equals to nearest value of 24.6 is 25. Okay. Then by find column of D1. D1 equals to x1 minus 25. Subtract 25 from x1. 24 minus 25, it is minus 1. 27 minus 25, it is 2. 26 minus 25, 1. 21 minus 25, minus 4. And 25 minus 25 is 0. And the total is minus 2. Okay, now squaring this D1. D1 square. 1, 2 square 4, 1 square 1, minus 4 square 16, and so on, and sigma d square will be 22. Okay, this is calculation for our first sample or sample number 1. Now write down sample number 2. Sample 2 x2, 27, 30, 28, 31, 32, 36, and total is 184. Okay, now find x2 bar. X2 bar sigma x2 upon n2, 184 divided by 6 is equals to 30.67. Again it is in decimal points, so we are assumed mean for x2, and the nearest value of 30.67 is 30 because it is round up value, so we are taking b is equals to 30. Afterward find out d2 is equals to x2 minus 30. Subtract 30 from each observation of x2. 27 minus 30, it is minus 3. 30 minus 30 is 0. 28 minus 30 minus 2, then by 1, 2 and 6. If we find total of D2, we will get total 4. And now our final column squaring d2. d2 square 9, 0, 4, 1, 2 square 4 and 6 square 36, and total of d2 square is 54. Okay, now we need standard deviation, combined standard deviation of both the samples. So first we are finding separate variance for both the samples, respectively s1 square and s2 square. So first s1 square. Formula of s1 square is sigma d1 square upon n1 minus sigma d1 upon n1 whole square. Okay, see, this is d1 square and this is sigma d1 and n is 5. Sorry. So we are putting the values. 22 divided by 5 minus 2 by 5 whole square. So 22 by 5 is equals to 4.4 and 2 by 5 is equals to 0.4 and its square is 0.16, and subtraction of 0.16 from 4.4 is 4.24. Okay. Now find s2 square. s2 square is equals to sigma d2 square upon n2 minus sigma d2 upon n2 whole square. Okay, this is sigma d2 square, n2 is equals to 6 and sigma d2 is equals to 4. Putting these values, so 54 divided by 6 minus 4 by 6 whole square is equals to 54 by 6, 9 minus 4 by 6 whole square is equals to 0.44 and subtraction is 8.56. Okay. Now remember s1 square is 4.24 and s2 square is 8.56. Okay. Now we have to find combined variance, then by combined standard deviation for both the samples. So s square is equals to n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. n1 is 5. s1 square we find 4.24 plus n2 is 6 and s2 square we find 8.56 divided by 5 plus 6 minus 2. Product of these two terms is 21.2 and product of these two terms is 51.36 divided by 11 minus 2 equal to 9. So total of numerator is 72.56 by 9 and s square is 8.06. But we need value of s. S means standard deviation under root of s square. So s is equals to under root of 8.06 and it is equals to 2.84. Okay. Now we are going to find t calculated value. So t calculated value is equals to modulus x1 bar minus x2 bar upon s into under root n1 into n2 upon n1 plus n2. Putting the values, x1 bar is 24.6, x2 bar 30.67 minus s 2.84, n1 into n2 5 into 6 upon 5 plus 6. Okay. Now subtraction of modulus is 6.07 divided by 2.84. 6 into 5 30 upon 5 plus 6 11 is equals to division of these two terms 2.14 and division of 30 by 11 and under root is 1.65 and our last answer is 3.53. So t calculated value we find 3.53. Okay, now degree of freedom, n1 plus n2 minus 2 is equals to 5 plus 6 minus 2 is equals to 9, and if we see the table value we will get 2.26. Now compare both the values. This is our calculated value and this is our table value. See here, calculated value is greater than its table value. Here t calculated value is greater than its table value. So our hypothesis may be rejected. H0 may be rejected. So we can say that x1 bar does not equals to x2 bar. In other words, we can write there is no significant difference between two sample means.